Welcome everyone to the third lecture on programming in C++. So this is also the continuation of Introduction to C++. So in today's lecture, we are going to talk about functions, user-defined functions, and how they can be declared and how they can be defined. Also, we are going to talk about different techniques for passing arguments into the functions. We are also going to discuss reference variables and pointers, and we may touch uh, the arrays from C, and also we will understand different dynamic memory allocation and deallocation techniques in C++. The user-defined function. So as you have the knowledge of C, you might have known this term. You are well aware of this term, functions. So functions are very important in procedural-oriented programming languages. So it helps in dividing the tasks into modules known as functions. That means a whole task or a big task can be divided into small tasks using functions. So just we are going to revisit how functions were in C and how they are in C++. So pretty much they are the same. So for function declaration, so functions basically have three parts. One is the function declaration, also known as function prototype or function header, whatever you may call it. So it has function declaration, prototype, or header. So this particular part is optional. Then you have the function declaration, function definition, where you actually define what are the operations or what are the instructions that are needed to be inside that function. So in the function body, you actually going to define what are the steps or what are the instruction that you want inside the function as a body of that function. So function definition is the top, and the third one is called the function signature. So this function signature is used to call a function. So let's take a look at the syntax of function declaration. So for function declaration, you have a syntax like this: return type, then this function name, and for this function name, the naming of identifier rule is applied. That means a function name cannot start with a digit; it can only start with the alphabet or underscore character. Then in the parameter list, we pass some of the inputs or some of the arguments that we want to pass into this particular function. So function will work like this. Suppose function is working like a small program. So you give some inputs as an argument, and you produce some result. So you produce some outputs in terms of return value. So this return type actually specifies what will be the output of the function. So this is a function, suppose. So this is our function. So this return type actually specifies what is the return value we are getting from the function, and parameter list is the inputs. That is, what are the arguments that will be given to the functions. For that, something will be written. So for example, we can take a look at this pow function. So suppose 2 comma 3. So if you put pow 2 comma 3, it will produce a result 8.0. So that is a double or float. So there is a double value. So that means this pow function actually returns a double. So the data type or the return type of this pow function is double. So similarly, for user defined functions as well, we have to specify the return type of the function, and also we have to mention the parameters. So these are the parameters to power function. That means these are the inputs to the power function, and it computes 2 to the power 3. So how this 2 to the power 3 is computed from this input is written inside this function definition. So we basically write, so this function declaration tells, or this function name actually tells what this function is going to be, what will be the input to the function, and what will be the output from the function. This function definition actually specifies how these inputs will turn into return. So this is how you can define a function definition. So similar to function declaration, but note that the function declaration ends with a semicolon, whereas function definition uh, starts a function definition starts with a brace and ends with a brace, and inside that we have the function body or the block of the functions that these statements are going to be executed whenever this function is being called. Now take a look at the example. So I have defined a function max that will find the maximum of two numbers, number one and number two. So this is a function prototype, or you can have this one as also a function prototype. So in function prototype, you don't need to always you don't need to mention the variables. In function prototype, you don't need to mention the variables. So that's why this particular statement is equivalent to this statement. So here we have mentioned what type of data we are going to give it to the max and what type of data we are getting from the max. And you can also put the variable names. That is not a problem. So that's correct in case of function definition or header. Sorry, function declaration or header. In function definition, we have defined this particular function. So we have used the return type, we have used the function name and argument list as we have given here. But if you would have used this particular header file or function header, then you can change these names as you want. So here we have calculated whether two numbers are which of the number is maximum. So we have checked if number one is greater than number two, we have written number one, is else we have written number two. So this thing will be easier to understand if you have knowledge about C. That's why I said in the requisite of this course that you must have some knowledge about C programs. I'm not going to details about this because you have learned all of these things in C programs. Now, calling a function, that means how we are going to use the function we have written now. So calling a function means using a function. You simply need to pass the required parameters along with the function name. So that is the function signature. So for max function, this is the function signature. So function name along with the original arguments is known as the function signature, and we use this function signature to call a function. Now in case of return type, we have a special return type in case of functions, that is void. Void means it doesn't return anything. So if functions returns a value, then you can store return value. That is this max function returning integer. So we have to use an integer variable or higher order variable, that means either double or float, to store this particular value or this particular return from this max function. But if it is a it returns or the function returns void, that means it doesn't return anything, then we don't need this particular statement. We can omit this particular statement if the function doesn't return anything. For example, strcat. So this method is written in string.h. I hope you had heard this term. String.h includes all the functions that are related to strings. So strcat function, actually what it does, it actually concatenates two strings into one, but it doesn't return anything. So strcat function is one of the examples where void is the return type. Now let's talk about formal parameter and actual parameter. So formal parameters are known as those parameters that are used at the time of declaration or defining the function, whereas actual parameters are the parameters that are passed as the argument while calling the function or used in function signature. So in the previous example, this number one and number two are the formal parameters, and this 5 and 12, so they are the actual parameters. Now we have three different methods in by which we can actually pass values to the function. So they are called call by value, and call by reference, and call by pointers. So we will learn all of them now. So in case of call by value, whatever change the changes that are made to formal parameter will not reflect the actual parameter. That means these x and y are the formal parameters here, and x and y, these are the actual parameters here. So they are the formal parameter, and they are the actual one. So in case of call by value, uh, this whatever changes we are making in this formal parameter will not reflect in the actual parameter. So what is happening in case of this calling? So this value of x, the value of x is being copied here, and the value of y is being copied here. So what is happening in the memory? So we have suppose x and y. So suppose we have x is equal to 10, y is equal to 20. So whenever we call this swap xy, what is happening? A new variable x is created, and this value is being copied here. So 10 will be here, and another new variable y is created, and this is copied there. So these two names are same here, but if these two names are not same, it will be easier to understand. But this is actually happening. These values are being copied to this new variables. So now, if you change it to 15 and you change it to 10, that will not reflect in this actual pointers. So that is why they are called the call value. In call value, these values are being uh, copied into the formal parameter, and that's why we are trying to swap these two numbers x and y. But if we run this particular program, the output will be 10 and 20. So we have somehow change x to 20 and y to 10 in this particular code. But this code, or the reflection of this code, will not be reflected here, because we have sent the parameters x and y as call by value or pass by value. Then we have call by reference and call by pointer, where the changes made to the formal parameter will be reflected in actual parameter. Uh, so, uh, so the changes we are going to make in the formal parameter, that means in the function definition to the parameters, they will be actually reflecting in the actual parameters as well. That means the values that are going to be updated in this formal parameter will be also updated in the actual parameter. So for this, we have to learn two types of variables. One is called reference variable, another one is called pointer variables. So reference variable is a new concept in C++. It was not present in C. So what it does, it actually creates an alternative naming for the existing variable. So what is happening if we have this kind of statement? So ampersand operator is used to actually declare a reference variable. So if we have int x is equal to 10, we can create the reference of this x as int ampersand reference is equal to x. So that means that in memory we have 10x, and when we create a reference to this particular x, what it does, it actually creates or renames or create a alias of this particular variable. So whatever changes you are making to ref will be reflected in x, whatever changes we are making to x will be reflected in ref. So for that, please follow this example. So we have x is 10 and reference variable x is equal to x. So if we set ref is equal to 20 and try to print x, it will be 20. And when we set x is equal to 30 and try to print ref, it will be 30. So follow this particular instruction. So this is how we can create reference variable. So this kind of instruction, this particular instruction will help in passing an argument as a reference. So this is the example of call by reference. Now look at this architecture or structure. So int x, it is a reference variable, and int y, it is a reference variable. So what is happening when we call this swap function? What is happening here? Implicitly it is happening ampersand x is equal to x, and or comma int ampersand y is equal to y. So this is happening. And now look at this particular statement. Int ampersand x is equal to x, int ampersand ref is equal to x. This is how we are actually creating the reference. So that means uh, in memory we have x is equal to suppose 10 and y is equal to 20. So now, as we have created x and y as reference, what will happen? X and y will be treating this element only. So now we have swapped the values of x and y. That means now x becomes 20 and y becomes 10. So this particular operation will actually reflect this particular case. Oh, sorry. So this will be x and this will be y. So it will be reflected in this particular variable, and the answer will be 20 and 10. So after executing this particular uh, code, the answer will be 2010 because whatever changes we have made here using the reference variable has been reflected here. So for call by pointer, you already know what a pointer is, right? So pointer variable can be declared as int this p is equal to ampersand of say a integer variable. So we have int a is equal to 10. So this. So ampersand of a means address of a, and that is assigned to this pointer p. So what is a pointer variable? Pointer variable can point to a variable location. Like in this particular statement, what is happening? We have a 10 and we have a pointer variable this, and suppose the memory address is 1010, so 1010 is residing here. So this is the concept of pointer. Pointers actually point to a particular variable. So using the pointers, so look at this particular statement again. So to declare a pointer variable and assign an address to that, this is the statement int pointer is equal to ampersand of the variable. So what is happening here? We have this swap function here again, and we have this statements. So what is happening internally here? Int pointer x is equal to ampersand of x, comma int pointer y is equal to ampersand of y. That means we have in the memory, suppose x is equal to 10, y is equal to 20, and we have their memory address 1010, 1012 suppose, or 14 suppose. So what is happening here? Uh, we are creating a pointer variable, say x, and pointer variable y, and we are storing 1010 and 1014 here. Now we know that using this pointer operation, pointer p, we can easily access the value of a in this particular case. So similarly, using this pointer operation, we are accessing actually this value of x and y. So that those actual values are being tempered and they are being swapped with each other, and again the output for this particular code will be 2010. So this is how call by pointer and call by reference actually working. So both of them actually does the same thing. Then why there is a reference when we already have the pointers? And what are the differences between this reference and pointers? So reference used to refers an existing variable in another name. So whenever we are going to initialize or create a reference, we must have to initialize that pointer. That reference. Whereas in case of pointers, we use they are used to store addresses. So sometimes you may have some value on that particular pointer, or you may not. That means references are not exactly variables. They are just the names, new names to an existing variable. Whereas pointer is itself a variable and it also has their own address space. Whereas reference cannot. Reference doesn't have their own address space. References cannot have null value assigned. Pointers can have null value assigned. So references, as they works on only existing variable, so we cannot have some null value assigned to the reference. Whereas in case of pointers, we have some null values. So references must be initialized at the time of declaration. As I said earlier, that as it is dependent on an existing variable, you must declare or you must initialize the variable on the declaration. In case of pointer, that is not necessary. We can easily declare pointer like int star p is equal to null. So we can easily define a pointer, or rather we can define a pointer like this as well. That means it is by default initialized with null. So it shares the same memory address with the original variable, also take up some space on the stack. So basically, reference variable is sharing the same memory address. That means reference variable and the original variable has same memory address. Whereas in case of pointers, that is not the case. If we have int a is equal to 10 and int pointer p is equal to ampersand of a, the address of a, say 1010, may not be equal to the address of 2020. This is the address of p and this is the address of a. So the address of star p is equal to address of a. That is true because star p is actually denoting a. Uh, but address of p is not equal to address of a. That means pointer address and original variable address is not same, and also pointer has their own size on the stack as well. So this is the difference between references and pointers. Now, recursive calling. This is another interesting technique in functions where we call the same function inside the function definition. So while declaring a recursive function, we should have an endpoint. That means we must declare an endpoint inside the function. So recursive function always or actually works like an infinite loop. So you are calling your own function within the same body. That means in the function definition you are calling the function that becomes an infinite loop. So you must have an endpoint somehow to break out of that loop and progress from start to end. So we have started from something and we will reach that endpoint to reach our goal. So for that we have this particular example here. So int fact int n. So this particular function will find the factorial of n. So what is the formula of factorial of n? So n is equal to n multiplied by n minus 1 multiplied by n minus 2 and so on. From this we can conclude that n is equal to n factorial is equal to n into n minus 1. So this is the formula of recursion. This from this particular equation that n factorial is equal to n into n minus 1 factorial, we have concluded that we can actually manage to do the recursive version of this particular function. So what we do, we first of all denote the end condition. So for any n, if n is equal to 1, return 1. So that means if n becomes 1, we will return 1. In any other case, what we are going to do, we are going to return n into factorial of n minus 1. That means this is the call to this particular function. So this is the function and this is the function definition. So what is happening here, we are using, or the compiler or the CPU actually using the stack area to run this particular type of code where they calculate the n multiplied by, so suppose you are trying to call fact 5. So what is happening here, they put 5 here and then they try to find out the factorial of n minus 1. So that is factorial of 4. Then they put 4 here. Then they try to find out factorial of 3, that is 3, then 2, and then they find the factorial of 1. So when they come to that factorial of 1, they return 1. So after that return 1, they actually pop one item, then perform the multiplication, and you eventually get the result of 120. So this is how recursive functions work. Recursive function means calling the same function inside the function definition. So you should have an endpoint in somewhere so that you can come out of that particular infinite loop kind of thing. Now let's discuss array, and declaring an array is same as it was in C. So for that you must write the type of the array and the array name with the array size. This is the same way we used to declare an array in C. So for example, double balance 10. So we have defined an array. The name of the array is balance and the data type of the array is double. And also we know that this is called balance. So address of the first element is actually the base address. So what is happening in the memory? So we have this kind of thing, and say p0, so 0 1 2 3 up to say 9. So this is balance. So this is something like this is happening in the memory. That means a memory allocated for 10 double numbers, and the first address is assigned to this particular variable balance. So initializing an array, so what we can do, double balance 5. So we can mention the size here and then initialize all the objects using a set kind of structure, and each item separated by comma. Another way of initializing this, like double balance without any size, and then put this particular value. Now, what is the difference between these two initialization? So, if you put the size here, you cannot enter values more than 5. But if you don't put any size here, you can enter more than 5 values or any number of values, and the size of this balance will automatically be the number of elements in this particular set. So how can we access each of the elements? To access each of the element, we use the array name with the appropriate index, where index starts from 0 to n minus 1, where n is the maximum number of element in the array. So the array index starts from 0 to n minus 1. So passing arrays to a function. So we have already learned function, and now we are trying to pass arrays to the function. So there are three ways basically to pass array to the function using a pointer variable. So int param. So this will in this way we can pass array to a function. For sending or for calling this, we can write my function arr simply, where suppose int arr 20. So suppose this is an array of 20 elements, integer array of 20 elements. We can just send the array using a structure or function definition like this, void my function int star para, where we have passed this argument. So the function signature will look like this. You just only have to use the array name. In second format, you are going to specify the number of elements as well as the array name, and you also give this third bracket to denote that this is an array. So this is not a pointer way, this is not a pointer version. And similarly here also, if we have int suppose uh, x10, we can just call my function x. And now one thing to be noted here, so as we have mentioned the size here 10, we cannot have an array that has more than 10 elements. Then this only first 10 elements will be confirmed or will be captured by this particular variable. So you must mention, you must have the same number of elements or less number of elements in the actual parameter. In the third way, we don't put the actually the array name, array size. We don't put the array size. So it is similar. You can send any number of elements. So int x suppose 50, and you can call it as my function x. So I am not going into the details of these functions and all these things, because function and array, because they are already covered in C programming languages in details. So I am just recapping everything. So here is an example of array and functions as well. So we have this particular program. So we have this function double get average. So this function will get the average of all the numbers that are stored in this particular array. So we have we have used two arguments. One is the array, another one is the size of the array. Now locally we have defined three variables, integer I to manipulate the for loop. So what if we just omit I from here and put in int here, because we have learned in the previous class that variables can be declared anywhere whenever required. You can also omit this particular statement double average, and you can put a double here, because average variable is required at this point. Before this point we don't need this average variable. That's why I have kept this example like this, so that I can show you that this type of statements can be written for your productivity and readability increasement. So for int I is equal to 0, I less than equal to or I less than size I plus plus or plus plus I, what we are doing, we are trying to find the sum. So sum is equal to sum plus array I. So the use case of array is same as C. And then to find out the average, what we are doing, we are converting this sum, integer sum, into a double value, and then dividing it with the number of elements. So why we need this double? Why we need this sum to be converted into double value? So there are two type of statements basically. One is pure, not expression, a statement pure expression, and mixed expression. So in case of pure expression, what is a pure expression? Pure expression means expression where only similar type of data is available. That means a expression consisting only integers. So it will be integer expression. Expression containing only double. So it will be double expression. So they are the pure expression. And mixed expression means we have a mixture of int, double, float, something like this. Expression consisting int, double, float, and all this. So in case of pure expression, the resulting value will be of the type that are used in that particular pure expression. So if we have integer expression, so suppose this double is missing here. So if you have sum divided by size, so we know that sum is of integer type and size is also an integer type. So it will become an integer. So it will become an integer pure expression. So the result value from this will be integer containing all the values from the point. So that's why we make it a mixed expression using this double casting. So we have casted the sum to double so that we get a double value as a return. So in case of mixed expression, where we have multiple type of values together in an expression, the resultant value will be of the type that has the maximum size. So if you use int and float, so the resultant value will be in float, because float can handle fractional numbers where int cannot handle. So if you have int and double, or int, double, and float all, so resultant value from the mixed expression will be double. That's why we have to convert or typecast this particular sum into double to get the actual accurate average. Then we are going to return that particular average as a double format. So this is how you can pass an array and manipulate that array, whatever operations you want to perform on that particular array in this case. So what is happening in the main function? So we have this function declaration, then we have initialized this main. Here we have taken array of size 5, then we have also taken a variable average, and in that average we are calling this get average function with the balance and the number of element. Balance is the array name. So as the array name is passed here, this array will take all the values from this particular balance, and the output is being shown as the average. So this average will return or will get the value from this return average statement. So this is how arrays can be passed into a function. So function can return an array as well. So the operation will be simple. What we have to do, we have to make return a pointer. So int pointer fun. So this fun function will return a pointer to an integer. So what we are doing here, we are just creating an array inside this particular function. So int AR10, and we are adding two values in that particular array. So some operations on the array. So array 0 is equal to 10, array 1 is equal to 20, and then we are going to return that particular array. So what is happening here? We have created a pointer here. So this creating a pointer is itself creating an array. We will move into that as well. We will try to find out what is happening here. Uh, So we have called this function fun, and now we can access the array elements using this pointer 0 and pointer 1. So and these values are set here. That means this particular function has actually returned the array. That's why we can access this particular values, and the output of this particular program will be 10, 20. So this is how a function can return an array as well. Just you have to put the return type as int star. So let's discuss dynamic memory allocation in case of C++. So uh, this is the memory structure that is used for any C++ program. So in this program code, all the program codes are being stored while executing a particular program. So that program code is residing in this program code section. A stack is used to place all the local variables and the functions that are defined in that particular program. And a global area that is used to define the global variables as well as the static variables. And we have this particular heap. So in case of dynamic memory allocation, this heap is basically used. Uh, so this stack is used for static allocation. So what is a static allocation? So when we declare int a is equal to 5, so this is one kind of static allocation. That means at the time of running, sorry, at the time of compilation, we know where this particular value is going to be stored. That means compiler decides where this particular value is going to be stored. Similarly, int suppose ARR 5. So this also is a static declaration where uh, the location where this particular particular ARR array will be located is decided at the time of compilation, and all these variables are residing in this particular stack. What is called a dynamic memory allocation, or why it is called dynamic memory allocation? Dynamic memory allocation means when the memory of a particular variable or particular object is being created at the time of running. That means at the execution time or the runtime, if memories are created for a particular object or variable, that type of allocation is called dynamic memory allocation. And on that particular time, or on the uh, dynamic memory allocation, the space that is used is this particular heap, and this is actually dedicated for dynamic memory allocation. So in C, we have two methods actually. So in C we have two methods, malloc and calloc, that are used to allocate memory dynamically. Whereas C++, so this malloc and calloc still available in C++, but C++ users tend to use this new and delete operations. So basically this new operations to allocate memory. So this is new. This new is not a function. This is actually an operator, new operator. We call it a new operator. So C++ encourage us to use this new operator because some of the advantages of malloc and calloc we are going to discuss later. So new operator is used to create memory at runtime. The operator looks like this. So how can we use it? We can use it like this. So we have a pointer variable. So we know that whenever we talk about dynamic memory allocation, we talk about actually pointers. So what we can do, we can declare a pointer, say type pointer. So suppose int pointer p, and we can at the time of, so we can initialize it null as well, and you can afterwards you can declare, or you can create the memory for this particular variable. So we can write p is equal to new int. So it will create a space for this p to locate on. That means what is happening here, so first of all we have created p. So p is here, this content is null suppose. So the location of p is suppose 1010, and what you have done now, p is equal to new int means a new location that can store an integer, suppose 4 byte of space. So this can store an integer, so it has some address, suppose it has 2010. So this is the address where some value can be located. So what is happening after executing this particular statement? Dynamically a memory location is created and this pointer P can point to that particular location. That means 2010 will be here. So a new location is created. The location is unnamed. That means we have not assigned any variable in that particular location, but a pointer is actually pointing to that particular location. And whenever we are going to use star p, we are going to access this particular value. So if we set this value as 5, star p is equal to 5, what will happen? Here the 5 will be there. So this is how a dynamic memory allocation works at the time of running. So this is this two statement can be combined. This two statement can be combined into a single statement like this. So this two statement can be written as int star p is equal to new int. That means this p can be a location that can store a integer value. That means this is a location of 4 byte that can store an integer value, and p can point to that location, or p actually pointing to this particular location. That means p is pointing to that location. We have not any variable assigned to this particular location because it is a runtime memory allocation. And there is another method, dealloc. Oh sorry, not dealloc, this is delete. So delete operator is used to deallocate or delete the allocated memory through new. So whatever through this delete of new operator can be deleted using this delete operator. So the syntax is simple: delete the pointer variable. So what if we want to delete this pointer variable p, what we have to write? We have to just write delete 7. So this will delete the runtimely allocated pointer. So this is a good practice whenever you create some memory space. So after the execution of the program, or after at the end of the program, you must delete those pointers or delete those dynamically allocated memories for betterment of your memory management or the program's memory management. So this is there is an example of dynamic memory allocation. So we have created an integer variable, and this particular part is important. So whenever you create a particular dynamic memory, so whenever you try to create a dynamic memory, you should check for this particular error. So after executing this int p is equal to new int, if you found that p contains the value null, that means we can say that there are some errors and we cannot allocate that particular memory. So if p is equal to null, you can say that error occur, or some error is there, that means out of memory or whatever it is, that means your RAM could not support more allocations, so the allocation is failed and p has returned this null. So new operator will return a null if memory allocation actually fails. If not, then we have assigned p is equal to 5, and also we have printed the p, then we have deleted that particular pointer. So what is happening here? So similar thing is happening. So we have this p, so the address of p is 00, suppose something like this, and it can point to a location. So this is a 4 byte of space that can point that can store an integer. So we have created this link. So suppose this is 1010, so 1010 will be here. And now after executing this particular statement, what is happening? This 5 is happening here. And now you have printed that particular value. That means on the screen now you can see the output, that is 5, and after that you have deleted that particular pointer. Now what will happen if you put this particular statement here? If you put this particular statement here, then this particular memory that you have created, this memory will be deallocated, as well as this link will be broken, and you cannot access C out star P because P now pointed to a null pointer. That means this statement will be invalid if delete p is before this particular cout star p statement. So now what about malloc? So malloc allocates memory only. So malloc is still here. That means malloc is still supported by C++, but still C++ actually encourages us to use the new operator because malloc can allocate only memory. It cannot distinguish between different objects or different data types. That's why malloc actually returns a null pointer, and you have to convert this null pointer to whatever specific type of pointer you want. So if you have forgot the syntax of malloc, I am just recalling you. So malloc will be used as something like this. Suppose you want to create an integer. So what you write, integer p is equal to integer pointer malloc, and here size of int. So what we are going to mention here, we are mentioning how many bytes we want. We are mentioning how many bytes we want. That means we are mentioning the original or actual memory size. And also malloc returns a null pointer that is being converted to this integer. But in case of new, as you can see, if you write new int, it will understand that you have to, or it new operator has to create an integer object. That means it has to create a memory space for integer option. That means new can distinguish between different object, and that is the purpose of C++ new operator. So that's why instead of malloc, new operator is very much useful in dynamic memory allocation. So we can also declare arrays dynamically. So while declaring or while mentioning arrays, I have mentioned that declaring a pointer is actually declaring an array. So this is what happening here. So whenever using this kind of statement, you can declare an array. So the type of the array, name of the array with a pointer, and new operator with the type, what type of array you want. So this type and this type should be same, and then you have to mention the size. For example, this particular, consider this particular statement. So int arr pointer, so pointer array, or rather it is int pointer. The name of that pointer is arr is equal to new integer of 5. Now, to delete an array, you have to use just array symbol before the pointer name. So, in case of normal deleting, we just mention the pointer name. In case of array deletion, we have to just put this array sign. That means opening third bracket and closing third bracket. That will delete your array. So, what is happening here? So, whenever we actually execute this kind of statement, a memory for for this particular 5 elements, each having 4 bytes, suppose each having 4 bytes, 5 elements, for 5 integers a memory is created, and arr is now pointing to that particular location. That means arr stored the address, first address of those of that particular array, and after this, you can simply use it ARR as a array name or the base address, like you used to do in case of int ARR is equal to, oh sorry. So this statement can be said equivalent to this particular statement, and whenever we declare an array using this kind of statement, we can access all the elements using index. Here also we can access all the elements using index. So what we can do, we can access the elements using index. So what I have done here, I have put 1 2 3 4 and 5 in this particular array that is created dynamically, and then again I have displayed those numbers 1 2 3 4 5 in this particular order with an endln. So endln new, this is a new keyword, represent or represents slash n basically, and it is used with the cout. So this is a keyword that represents slash n. So this statement can be equivalent to cout arri with slash n. So that means after this number, we put a new line character. So endln actually creates a new line. And then we are deleting that particular array. So declaring a 2D array is also Very simple in case of uh, dynamic memory allocation. What you can do, you can just write type ARR is equal to new row and column. So you have to mention the row column. Uh, so using this, you can create a 2D array. So if you write int mat is equal to new int 3, so it will create a 3 cross 4 matrix. But to delete a 2D matrix, you just need to put a single third bracket, same as normal array. So this is how you can dynamically allocate memory for arrays as well. So this is the end of introduction to C++. On the next class onwards, we are going to talk about different features of object-oriented programming. We are going to explore all the features, how these features are being implemented in C++. We are going to understand that as well. And in the next class, particularly, we are going to start classes and objects that are called the heart of any object-oriented programming. So that is the end of this particular lecture.